Welcome back to the shop, guys. Not a whole lot going on here. Just did a little bit of rearranging. Took the stereoscope over here because this is where I mainly use everything, but did some playing around with some stuff. But first I want to give a shout out to a new YouTube creator, Adam L. I'll put a link in the description to it. This guy has a lot to share. He's done a few videos here. Go check out his channel, subscribe. This guy has a lot to offer. So, way to go, Adam. Bandsaw, the Wind bandsaw, I'm now on my third blade. It loves to crack at the splice. So, and Win evidently overhauled their website. They now have, after I don't know how long, years, they have the bandsaw blade in stock. So my advice and what I'm doing is you run the blade as slow as you can on the machine, minimize the flexing, and the blade will last longer. So 3 blades, that's crazy. Toollots.com, stumbled across them. Wow. TOOLOTS.com. There's not 2 L's in it. I'll put a link in the description to them too. Go check out toollots.com. It's crazy. I did pick up a new machine, which I'll share in a future video here soon. I think you guys would be really interested in it. But for this video, it's not a whole lot. I'm just messing around with finding a hole center with a test indicator versus edge finder. Sharing a little bit on another second 3018 CNC machine. How I solved a balancing problem that's on the chuck that's been bugging me for a long time. A very easy, simple solution. And then I'll just show some tool finds. So I hope it's worthwhile for somebody. And see you next Friday. I can't say that. I'll see you when I see you. Okay, I know the lighting isn't that hot. Sorry about that. But so off camera, I've already spun this thing around. Test indicator, I've got this mill on center and the axes are locked. So I want to remember this position. So you hit this guy, set absolute dimension, zero it out, set the dimension, close it. So I'm on absolute, it's 0. If I go to incremental, it's someplace else. So this guy, set absolute dimension, zero it out, set the dimension, close it. So he's zeroed out, incremental, he's someplace else. So I'll zero everything out here. Now if I go back and forth, they're all zeroed out. So I can take this guy out now, carefully. And you'll see the Z-axis, just how far up I am when I lower it for the edge finder. Put this guy to the side. And put him in there about halfway. Oh, I gotta lock the spindle up here. There. All right. So I'm in there. So the idea is I want to see if they match. And I'm about in the hole as far as the test indicator was. Put the light back up here and turn the mill on. So I just want to move. The x-axis is locked, so I just want to move the y-axis here to see about this hole. Alright, so give it some speed and come back. Is it going to hit? Yeah, it's hitting pretty much so where the test indicator was. Oh, it tripped. Went too far, too fast. There, it tripped. It's 127, and let me zero it out. See that it still trips in the same spot. 4, 3, 2, 1. Oh, it tripped. So I was off here. Oh, it's tripping at about 1. Dave, get your act together. No, it's not tripping. There it goes. Yeah. Alright, well, zero it out for what it's worth. Go to the other side and do the same thing. Slowly go in until it trips, huh? That trip? No. Wow. There. Okay, so if I hit him, say cut it in half to find the center, close it, I gotta move 124, right, 33, 10, 5, 3, 2, 1, 0. Okay, I'm zeroed. Now, 2,000ths off. That's better. Before, when I was doing, I was getting 8,000ths. So let me try the other axis and see what happens here. Go this way until it trips. There we go. Alright, so I'm just going to zero that one out by itself. Close. Go to the other side. Where are you? Jesus. Oh, it tripped already. I didn't see it. Oh, there it goes again. Alright, so it's going to trip back here. There. Okay, so if I take this guy, cut it in half, close it, I gotta go 128 to be on center, huh? 3, 2, 1, 0. Okay, so this guy said, oops, the hole is 2,000ths one way. This guy said it's 3,000ths the other way. It's quite a bit of difference. I just wanted to see exactly how sensitive is an edge finder. So I'm over here looking at the dial on this. And I know it's going to trip at around 17, but I'm just making really small incremental changes here. So back it out. Alright, so I'm going to come up here. Oh, I'm very close. I tripped already. Blew it. Alright, so 30. Where am I here? 20. So I'm at 25. And then I can go easily to 24. And it's not going to trip. So I go 24 and a half. I'm a half thou in. It's not tripping. 23. I know it's not going to trip because oh, it did trip. So that was a half a thousandth. It's detected right there. Let's try it again. Okay, 25, 24. Doesn't trip. 23 and a half is right there. Doesn't trip. Let's see if I can move it to 3/4. There's 3/4 and it tripped. So an edge finder is pretty sensitive within a few tenths, I think. Okay, what you see before you here is a second 3018. I didn't ask for it, but Banggood sent it to me. So cool, thank you very much, Banggood. I'm suspecting, I'm pretty sure, I don't know, suspect this is a very old machine, and that might be they just wanted to get it out of inventory. Some of the differences, is camera in a good position here? Push it down? I don't know, I guess. One of the things that was really curious is the table, it's two pieces. It's not one like the first Banggood 3018. So they give you two plates, which I have on the bottom here to join. This is one, and then that's the other one. You can see the seam in there. That's one thing. The other thing is, when do you ever see chromed motors? Kind of cool. I like it. The first 3018, they just painted the motors black. Decided I'm going to dedicate this one to the laser, and the other one will be the CNC. What else was there? They supplied, yeah, constantly loose. It's crazy. They supplied this guy with a bunch of Phillips screws, which you just couldn't torque down. Everything kept moving on it. And I'm not sure why this one's loose. I must have just forgot it. So I went to, yeah, it's completely loose for a reason, I guess. I was redoing these, all these. So yeah, I went to Industrial Metal Supply, picked up some 50 5mm screws, and the heads were too big for a bunch of places. So I spent the day taking 40 thousandths off the head of 50 screws to get them in here. So that's all done. I had to take everything apart again to get rid of all of them and swap it out with the stainless socket head cap screws. So that was another strange thing. What else was there that I remember? The main control board, and this is the guy, it came with a plastic piece because it doesn't fit like the other board directly in there. But this is a very old board. This is running GRBL 0.9, one laser port, but what really was a kick is there's a X, Y, Y, Z. I don't know any machine that would have two Y-axes. It's probably out there. If this were for a 3D printer, it'd have two ZX drivers. And they just say, what, 12 volt out, and this is a 12 to 30 volt out. So the spindle is driven by a relay. So I'm pretty sure this guy does not have variable speed. In any case, I'm just going to put one of the other boards from SainSmart on here that's running 1.1 so that I have the ramp capability for the laser. And they're saying that this looks like a laser socket here. So, well, again, I'm not going to use this guy, but you manually switch this between CNC and laser because in 0.9 there is no, I think it's $1.30. Well, there's no RPM setting and there's no laser mode setting. The cool thing about this is a little nano board, so I can take that off and experiment with it on a breadboard and do something else with it, perhaps, just to learn, because I've never played with that before. Something else I was going to say on that board, yeah, 0.9, okay, geez, my mind is going. Yeah, spindle motor goes in here. It's like a power jack, so they gave the cable for that and the two spades that go in the spindle motor. No chuck came with this guy. Big deal. I know I've got 2 extra chucks kicking around, but I'm not going to use the motor, so it's just a backup now for me, and I've got a lot of spare parts. They did deliver these wonderful little brass things to hold, boy, a lot of construction going on. Whoa, jeez, a truckload of concrete particles just went by. So I got a lot of different spare parts and stuff on this thing. Another interesting thing, anodized couplings here. When do you ever see that? So they're going to get the cost out of that and get rid of that. Another piece that's suspected this is older. Also, I never mentioned, I don't remember the number, but these 3 pots are current control. Go look on Google, I forgot where it was, but it'll show you how to adjust those things with a voltmeter. There's a test point and you spin them, and all 4 boards that I have were off. So you want to dial it in for 1.7 amps for these motors so you don't get these drivers hot or the motors hot, because they're going to be, you know, these things can be running for an hour or 2 depending upon what you're machining or doing. I think that's about it. I'm putting the older or the first generation laser on this one, and I've got a little problem here because the laser I can see is tilted, so I had a hard time getting it in there in the first place, so I'll have to take it out and see what's crooked or what's binding in there. Not much else to say about this, but I'm running out of bench space. I actually have no bench space, so this is going to go on a shelf that I have to make above the CNC, and I probably will angle this thing so I can easily put something on it. Oh yeah, that was another thing, because it's interesting once you've built one. Well, the first one, you're so busy trying to figure out how to put it together that you don't bother to question anything. The second one, I mean, I played with this, putting this together for over a week, but just thinking about things, and one of them is the rod coupling rail guides, whatever, that are under here. Depending upon where you put them, you can get a lot more travel. So right now, if I come all the way forward, I'm just off this edge, but no, I think it's the other way. No, yeah, it's the other way around. If I go all the way back, I'm just on this edge. If I come all the way forward, I'm way off the edge. So I've got 8.5 inches of travel on this machine because I put the couplings closer together, and they're actually looking under there, they're in the center. So in the first machine I had the couplings out further, so that limited the movement, and the main nut is in the center also here. I think that's about it. So soon you'll probably see this guy running. Kind of interesting, this was long. Oh, the other thing I was thinking is you can easily get this extrusion longer and get longer lead screws and stuff to really make this thing bigger, but because what was the longer one? I think the width, no, the 4 pieces, I don't know. One of these lead screws was way longer, so I could have just said forget this machine and use the parts on the other machine to make the table area a lot bigger. Alright, so I guess that's about it. Just kind of a discovery or so. I bought this guy some 40 years ago. He's really old. It actually had this tip in it, and it's pretty beat up nowadays. I've used this in the shop for everything. I've cleaned beach sand out of the kids' shoes. I mean, you name it. The car gets detailed with it and so on. But I was looking at it thinking, you know, this guy's in pretty bad shape. Still works fine. AM flow. For the heck of it, I searched on Amazon, and lo and behold, it was $10 or $11. Didn't have the fitting, of course. AM flow, brand new. It's like beautiful. So I had this, put it into service a few days ago, and thought, you know, while I've got this one, get rid of the tip. You can see how much the corners are worn out on this nut thing. So I machined a little brass nut and put this guy, this is the other one, yeah. This is the first one I made, and fairly matched the hole or whatever, and it does a pretty nice job. And then I thought, let me try real small. So I made this one. This has got a 1/16 of an inch hole. Man, if you want to move some stuff around, this does it. Let me tell you, 70 PSI. I mean, dust, you know how dust sticks to the surface and you have to actually just wipe it to get rid of it? This gets rid of it. So I'm really thrilled with this. I'm probably just going to put this and this in the drawer and keep this guy on the compressor. Since this is so nice, I should probably just swap the tips or something, but I just wanted to say AM Flow, it's on Amazon, $10 or $11, it was cheap. Well, just a little tidbit, kind of a thought, a discovery. I think everybody's seen in the videos because of the missing metal here. This is out of balance, and I had made a balancing jig, and I put prints up on the website. did everything, and it was an oddball place. I couldn't put the metal on the inside to balance it, and I tried a bunch of different things. I didn't want to start drilling into it to balance it, but all of a sudden it dawned on me, magnets. 2 little magnets, they're just sitting here. I could epoxy them, silicon them, something down, but it's brought the vibrations down to, I mean, pretty much 0. And it's kind of funny where they are, because there's missing material here. And the oiler, somebody in the video had said, Dave, you're not accounting for the oiler missing material. So that's probably why it's shifted this way a little bit. But you can see, yeah, I would have had to put the weight like right in here on the inside, the gear's in the way. So for now, I'm just going to leave it like that. And I had just shifted them around, and I'm watching the light, seeing how much it's vibrating, and now it pretty much so just doesn't do anything. You know, and tried different speeds for different harmonics, and so I mean, it's great. So I'm loving it. Another quick little find, and I'll put a link to it in the description. Amazon, $30, so they're about $10 each. But I was looking at the picture, and they were like gorgeous looking, so I was hoping. And they are indeed incredibly sharp and nice, but the problem is, which I again don't understand, drill bits are always undersized. So I was going to play with the 4mm, drilled a 4mm hole, which of course is undersized. The screw fits in there perfectly, even though it's a small hole. But the tips are oversized. So you got an undersized drill bit, and you're going to use this guide. Pull it out. You're going to use this guide to go into the hole, and it won't fit. And I'm looking at these going, this isn't a cutting edge here. So it kind of went in, and it clogged, and it stopped. So I had to come back and over drill the hole to 4.5mm. Now this would go in, of course, and I think I got some chatter going, and I think it's because it was allowed to wobble around. I don't know. If any of you guys know what it's supposed to be, is this supposed to be accurate in 4mm or what? Please leave a comment. But it did a fantastic job. Even with the chatter, I was able to slow it down, and just went right in beautifully. So, and it fits the cap head screw perfectly. So again, I'll put a link in the description, but I measured every one of these guys, and they're all oversized.